In this video, we will get introduced to the idea of loss functions. We'll explain two commonly used loss functions in regression problems. A quick recap from last week. A classification problem is one in which the output is a category or a class. A regression problem is one in which the output is a numerical value or a vector of numerical values. As we have mentioned before, many problems in machine learning are optimization problems, where we are trying to either minimize or maximize the value of a function with respect to the parameters. The function is called the objective function. A simple example showing the objective function with respect to a single parameter is shown here. When we are solving a minimization problem, the objective function is called a loss function or a cost function. Let's look at a simple problem where we have an input x and an expected output y. We are training a machine learning model, and with the current parameters, it gives an answer y hat. Ideally, we want the value to be y. So we can calculate the error e equals y minus y hat. Of course, we do not care about the sign of this error because any deviation from y is not desirable. There are two ways to make the error positive. We can work with the square of the error, or we can work with the absolute value of the error. So we can say that our objective is to find parameters that minimize either the squared error or the absolute value of error. However, there can be many data points in the training set. Let's say there are n data points. We want to minimize the error over all data points. So we get the sum of squared errors or the sum of absolute errors for all data points. We don't want this quantity that we are minimizing to depend on the size of the database. So we can divide the sum by the total number of data points. This gives us mean squared error or MSE. And when we are using absolute values, it gives us mean absolute error or MAE. These are two loss functions that are very common for regression problems. Now let's see how the problem changes if the output is not a scalar but a vector. So our ground truth output is also a vector y, and the predicted output is given by a vector y hat. Notice we will use bold font whenever we are referring to a vector or a matrix. In this case, the output vector has m elements. We can calculate the error vector just like before by subtracting y from y hat. To calculate the square of the error, we simply take the L2 norm of the error vector and square it. L2 norm of any vector is simply the square root of the sum of squares of all elements. Now, suppose you have a vector of 3 elements, say v1, v2, v3. Then the L2 norm of this vector v, which consists of 3 elements v1, v2, v3, is simply v1 squared plus v2 squared plus v3 squared square root. So that's called the L2 norm. And this applies to any number of dimensions. If there were n dimensions, we will simply go v1 squared all the way to vn squared. We will add these numbers together and take a square root. So that is called an L2 norm. And you can imagine this L2 norm is basically a measure of distance. Similarly, we can calculate the absolute error, which is simply the L1 norm of the vector. L1 norm of a vector is simply the sum of absolute values of its elements. Again, giving the same example, if we had a vector v which had 3 elements, v1, v2, v3, then the L1 norm would simply be the absolute value of v1 plus the absolute value of v2 plus the absolute value of v3. And just like before, to get the mean squared error or the mean absolute error, we divide the sum by the number of data points. These two loss functions, MSE and MAE, are commonly used in machine learning for regression problems. If the data is well behaved, we typically use MSE. If the data has outliers, MAE is used. This is because using mean squared error, we use square terms. And if the error is large for one data point, the total error will be dominated by this one data point. Such data points are called outliers, and we don't want our training process to be dominated by a single data point. So when we have an outlier or a few outliers, in that case, instead of using MSE, we can use MAE, which is not affected by outliers as much because it doesn't have square terms. It has absolute value terms. That is all for this video. In the next video, we will learn about loss functions used in classification problems.